Okay, now last time we talked about density curves. This time we'll be talking about normal distribution. Now, normal distribution is a measure of something that's pretty close to not normal per se, but doesn't have any bias, is pretty randomized, but it still follows a type of pattern. Okay, and that one is going to be a perfectly symmetrical type of normal curve or normal density curve. Okay, and then right in the middle you would have your mu alt 230 would be equal to your median, which would be equal to your mode. Okay, so all three would actually be right in the middle. So let me move that over a little bit. There we go. Okay, so all three would be the same. Alright, now if you'd like to, you can use the other alternate standing, which would be x bar, is just how we type that out. Okay. Alright, so everything's all set up right in the middle. It's just a beautiful, gorgeous thing, and it just follows some distributions. Okay, let me go back to that paper from Purdue. It's a really good one that just goes in depth into all the stuff I want you guys to be able to learn. Okay, so normal distribution curves denoted by n parentheses mu comma sigma are particularly important in class of density. It's a type of density curve that's very important. They have the following properties. They are symmetric, unimodal, bell-shaped, so that's perfect. Okay, the mean mu is always the center of the curve, the peak. Standard deviation, sigma, controls the spread of the graph, whether it's wide or narrow. Probabilities are just the area under the curve, integral, between two points of interest. Total area under the normal curve is 1, or 100%. And curve stretches from negative infinity to positive infinity, but the area under the curve gets very small the farther away you get from the mean. Okay, now this is hugely important. The 68, 95, 99.7%. So normal distributions. But basically, we talked about standard deviation being about how far you are from the middle of the graph and everything. But I want you guys to understand this. This is hugely important. Where is that one thing? I'm sorry, I'm trying to look up the normal curve. Oh, there we go. I really like that one. Okay, so in the normal distribution with mean mu and standard deviation sigma, approximately 68% of the observations fall within one standard deviation of the mean. So above would be 34%, below would be 34%. Okay? Within two standard deviations would be 95% of all the data. So all of this is 95% of all the data you're going to need if it's been normal. Alright, and within three standard deviations, it's going to be a 99.7%. And let me give you something from Math is Fun that just really does a really good job of explaining the percentages exactly. Okay, now this is also half standard deviation, so in more detail, standard deviations right here would be here. So if you want within a half standard deviation of being plus or minus of the mean, you would have 38.2%. If you wanted within one standard deviation, you would add another 30%. So that would be 68.2% here. Okay, and you just move on and move on. And this is just a gorgeous picture of just everything that you're going to need. Okay. Alright, now it also has something underneath here, and you need to understand this. This is the percentages you're going to be getting. Okay, so this is the cumulative percentages. Okay. And there's some important numbers. So if you want the collective amount of people who get above from 3 standard deviations below to above the well, here. Okay, let me rephrase that. Okay, here's how you read it. Okay, it's in the middle, it's in the median. Okay, so 50% of the information is going to be on the left side, 50% is going to be on the right. And it's going to be below the median and above the median, which makes sense. It's the median, it's the mean. Everything should be equal. Okay, but when you read the probability percentages, and you will read this later, you read it as you're just adding the cumulative percentages from left to right up until a certain point. Okay, so if someone asked you, what is the probability of this situation being at 1.5, and the 1.5 they give you is the standard deviation. So you would line this up with the cumulative percentage, and you would say it's a little bit under 95%, maybe 94%. So 94% of the data is going to be within that range. So the probability of getting some data to within a positive, a z-score of 1.5 is going to be that. Now if they said a z-score of negative 1.5, okay, it's going to be a little bit over 5%, maybe 6.5%, maybe 7%. So that's what you would actually say. So that's the probability of picking some data within that range. Okay, so that's the tough part about doing statistics in the beginning, is you're like, what is this z-score stuff? But you just use the z-score just to work it out. And the z-score we'll talk about in a little bit. But the z-scores are where you get it. And so when you're doing probability of some of this stuff, it just know that those numbers that you're going to be using are z-scores. And if you go to mathisfun.com, this is a really great table right here that just uses everything. The z-scores are these numbers right here. And they usually tell you the standard deviation. So if they say a z-score of 1, that's 1 standard deviation above the mean. If they say z-score of negative 2.5, that's 2.5 standard deviations below. And you would just count the information to the left. So like, for example, there's only 0.5 and 0.1 here, so it'd be 0.6. All right. Whereas if I was looking at 2, I would add up 4.4, 9.2, 15, 19.1, 19 all of these. Well, just basically, if you go up to this point and add up all these numbers, okay, and then add it with 50, because this is going to be 50 no matter what, you should be able to get the actual probability percentage. And so that's where we're going to be going with this stuff, and it's really cool. All right, so that is it for normal deviations or normal distributions and stuff, and we'll talk more in depth about it in a sec. Thank you.